A few more error codes in regards to the E10 is going to be an E-10W, which is an internal memory error with our high limit PCB here. So what we could end up doing if we're seeing that E-10W is, of course, first power the unit down and power it back up to see if that error code goes away. However, if it doesn't, we want to go ahead and power the unit down for safety, and then we want to disconnect our connectors here, and then we're going to pull this PCB off of our PMU board and then reconnect it, so basically we can clean those connections there, hook everything back up, power it up, and see if that took care of the issue. If it didn't, it's going to wind up being a problem with our high limit PCB board here. Now another error code we could have is an E-10V, as in voltage, and once again that's an internal voltage issue with this high limit PCB, because of course remember our PMU is powering up this PCB with 24 volts DC, and as I mentioned, that's an internal voltage issue with this PCB board. So we could do the same troubleshooting for that E-10V as in voltage error code as what we did for the E-10W, and basically power the unit completely down for safety, unplug this high limit PCB from the PMU board, and then reconnect it to see if it was maybe just a connection issue, turn the unit back on and see if that takes care of it. If it does, great. However, if it didn't take care of it, then it's most likely going to wind up being our high limit PCB board, or last but not least, potentially the PMU board. The last E10 error code we're going to cover is going to be an E-10P, as in probe, like probe for our high limit. And basically the logic behind that error code is our high limit PCB board here is reading that one of our high limit probes is shorted. Since we have two for a full vat, remember we would only have one for a split vat, but basically the PCB board is reading that one of those probes is shorted, or it could end up being a bad high limit PCB board that's reading that that's shorted when it's really not. So what we could do to troubleshoot that is, of course, power everything down for safety, unplug our probe connector right here. We could check our probes to make sure that they are working properly and they're calibrated. We could check that with resistance, make sure that they're not shorted. And if they're okay, then we know most likely it's our high limit PCB board. Now, one thing we could do to confirm that is, once again, with everything powered down, we could actually swap this high limit PCB board, just this board, not our PMU, with a fryer over to the side and see if that problem follows that high limit PCB to that vat, or if it stayed with this vat that was originally over here. Because if it stayed over here, then we know it's our probes. However, if we put this PCB board over to the other vat and then the problem started on that other vat, then we know it's the PCB board. So that's a quick way that you could troubleshoot it.